It's 2:00 a.m., and your laptop is basically burning a hole through your desk.
Right, but not because you're playing some high-end game.
Exactly. It's because you've successfully tricked it into pretending it's a $50,000 enterprise data center. Today, we're diving into an exploration into the source material, specifically a guide by Abhishek Mishra titled Learn DevOps in One Night.
And the mission here is really cool. We're looking at how to transform a standard everyday laptop into a professional-grade DevOps laboratory.
Yeah, moving from just, manual clicking around to a fully automated CI/CD pipeline. The big picture tech stack features Proxmox, Terraform, Ansible, and Jenkins.
Right, and the whole point is to understand how these tools actually talk to each other. You want to create this DevOps loop where a simple code push to GitHub just automatically triggers a web server deployment.
Without you even lifting a finger. But, well, before we get to that awesome end state, we have to talk about the foundation, which honestly sounds like a total mess on paper.
Oh, it definitely does.
You start with Windows 11, and then you run VMware Workstation Player just to run Proxmox version 9.1.1. And then you're putting containers inside that. I mean, is setting this up like building a Russian nesting doll of computers? Why do we need this inception level of nested virtualization?
That's a totally fair pushback. I mean, why not just run Docker on Windows, right?
Exactly. Save yourself a massive headache.
Well, if you just want to run a simple app, yeah, absolutely use Docker.
Yeah.
But we aren't just running an app here. We are simulating a bare metal data center.
Oh, I see.
Proxmox is a bare metal hypervisor, so it's designed to sit directly on the hardware. By using nested virtualization, basically going into your settings and enabling VTX-HOUNCY, you're letting the virtual machine act like real hardware.
Right, so you're learning how actual cloud providers manage resources. But wait, how does a standard laptop not just totally choke on that? The host machine has an i5 processor and just 16 gigs of RAM.
It is a literal fight for survival between your host OS and your lab. If you give Proxmox its required 10 gig slice, Windows is basically gasping for air on the remaining 6.
Wow.
But that's exactly why we use LXC containers inside Proxmox instead of full virtual machines. Full VMs emulate an entire computer's hardware, which is just way too heavy.
And LXC containers are lighter.
Way lighter. They share the host's kernel, making them lightning fast and super lightweight.
Okay, that makes sense. But wait, what about the RTX 3060 GPU that's mentioned in the laptop spec?
No, you basically just ignore it.
Really? A high-end graphics card and it's just a paperweight.
Yeah, I mean, in this world of CLI-driven automation, raw compute and RAM allocation are what actually matter. Graphics are totally irrelevant here.
Crazy. Okay, so once our nesting doll is stable, we move to building the infrastructure on the control node.
Right, using infrastructure as code or IAC with Terraform.
Yeah.
You're writing code to tell Proxmox to build a container.
But the guide highlights a massive roadblock here, right?
Yeah, the aha moment. Initially, you might try using the standard Telmate provider, but the guide notes it's super buggy and throws permission errors.
So you have perfect logic, but it just won't work.
Exactly. Terraform providers are basically API bridges. If the bridge is broken, your code cannot cross. So the pivot is switching to the BPG Proxmox provider, specifically version 0.46.0.
It really shows that ISC isn't just about writing the code, it's about choosing the right translator for your hardware.
Absolutely. So Terraform builds the house, and then Ansible comes in to move the furniture in.
I love that. And in this case, the furniture is an Nginx web server configured via an Ansible playbook. There's this concept mentioned, idempotency.
Oh yeah, idempotency is crucial.
That basically means you can run the same script twice and it doesn't break things.
Precisely.
Sure.
If you tell a dumb script to turn on a light that's already on,
Yeah.
it might break the switch trying to force it.
Yep.
But Ansible checks the state first.
So if the light is on, it just moves on to the next task.
Right, which makes the whole process completely predictable. And that predictability is the only reason the final stage, the CI/CD loop with Jenkins, actually works.
So Jenkins is the brain connecting the lab to the outside world, like GitHub.
Yep. Though getting it running involves some technical pivots too, like moving away from the standard Debian repo to the Jenkins war file method because of some pesky GPG key issues.
Right, and it strictly requires Java 21. But the real success criteria here revolves around the Jenkins file, and the guide points out this crazy trap.
Oh man, the Jenkins file trap.
If you name the file with a lowercase j instead of a capital J, the whole multi-stage pipeline crashes. I mean, why does a single capital letter break the entire chain? It feels so pedantic.
It does, but it's the underlying engine. Jenkins uses Groovy, and it runs in a Linux environment. Linux treats a capital J and a lowercase j as two completely different things.
Wow.
It's a harsh reminder that at this level of automation, precision just isn't optional.
But think about it. If your pipeline fails because you had a typo in your password file or a lowercase letter instead of a capital one, you've actually succeeded, haven't you?
Exactly. The system did its job by preventing a bad deployment. A failed pipeline in your lab is a bullet dodged in production.
That is just so empowering. You go from a blank laptop to a self-healing system using the exact same init, plan, apply workflow used by giants like AWS and Google Cloud.
And this lab is really just week 1 or 2 of a much larger learning roadmap.
Which brings me to a final thought for our listeners to explore on their own.
Let's hear it.
If you can simulate an entire enterprise data center inside a single laptop on your kitchen table in one night, does the physical location of the cloud even matter anymore?
Oh, wow.
Or is a cloud now just a philosophy of how we handle code? Something to mull over. Thanks for joining us for this exploration.